Good day, everyone. Welcome to Chemistry with Professor John. All right. Hope your day is going well. Okay, we will be talking about atoms, molecules, and ions. These are the fundamental particles of matters, right? Okay, we'll be looking at the early atomic theories and also modern atomic theory, and those are the ones that lead to the atomic structure, isotope, ions, and so on and so forth. And finally, we'll end with pretty good stuff that's naming molecular and ionic compounds, okay, known as nomenclature, okay. Early atomic theories, this is around 400 BC, okay, so that's what, more than 2,400 years ago. Democritus already knew matters composed of tiny particle known as atoms. And then later, it's around 1800, John Dalton put together a atomic theory which composed of four main concepts. The first one, each element is composed of tiny indivisible particle called atoms. And Dalton also conclude that in a chemical reactions, atom, the tiny particle of one element cannot change into atom of another element. That's pretty good conclusions, right? There are only rearrangement of atom attachments. Okay, so basically, atoms just moving around and stick to other atoms to form something new. All right. Number three, concept number three, all atoms of a given element have the same mass and other property that distinguish them from atoms of other elements. In other words, if you take an atoms of gold and you take an atoms of silver, they are different. Makes sense, right? In terms of mass and other properties. And finally, number four is really good one. Atoms combine together in simple whole number ratio to form molecules of compound, like water, H2O2. You guys see the ratio is very specific. It's 2 to 1 and it's 2 to 2, okay? Okay, so these are the very specific whole number ratio. Okay, so those are the early theory. The modern theory looked further into the structure of an atoms, and starting with J.J. Thomson, who discovered electron, tiny particle, as one of the particle of an atoms, using a cathode ray tube experiment. You can check out the books. There's a picture of the cathode ray tube experiments in there that send out particle known as electron. Now, the charge to mass ratio is negative 1.76 10 to the 8 coulomb per gram. Okay, all right, that's a lot of electrons. The remember hydrogens, which is positive ion, the charge is positive. That's 9.58 10 to the 4 coulomb per gram. All right, so that's a lot less positive charge per gram. The Thomson, if you look at the books, also proposed the plum pudding model of an atom. So basically, plum pudding, basically, Thomson proposed you got a positive, you got a negative, you got a positive and a negative alternating, just so positive and negative all around, right? That's called plum pudding. Uniformly, okay, that's what Thomson proposed. That's a plum pudding model. Well, that's not the case, okay, later on Rutherford discovered that, that's not the case. In the center, you got all this cluster in the center. That's called a nucleus. And then you get all the negative outside in different, you know, regions. That's what Rutherford proposed. That's the actual structure of an atom. Now, inside is positive, okay, and spaced out by the neutral, okay, particle. So Millikan and other scientists discover the charge of the electron and the actual charge of electron, which is very tiny, and also other scientists help to discover all the particle. This is an atom in the modern theory. Okay. Now, so inside is the nucleus, which contain proton and neutron, P and N, and then all these negative one, we call them electron. Okay, so lots of them, right? So on and so forth. Okay, so that's the modern theory. Now we got a good picture of the structure of an atoms. And later on, the periodic table would establish, and in each element, you notice that has two numbers. The larger numbers is the atomic mass, and the smaller number is the atomic numbers. Now, they don't have to be this order. You can also write the mass on the bottom and the atomic number on the top. You can write, many different way. So the mass is the number of proton plus the number of neutron. Don't forget that. Okay, the atomic number is the same as the number of proton, and that's help to identify the elements as much as the symbol does. Okay, if the atom is neutral, zero charge, so number of proton must equal to number of electron, because proton is positive, electron is negative for each. So they have to be equal, the quantity, to cancel out, right? Isotope from the same elements, okay, there's different kind. They have the same number of proton, but they have different neutron. So they have different mass. Same number of proton, different mass, or different number of neutron. Okay. Okay. Look up in the textbook for magnesium. You should get 3 different isotopes: magnesium 24, magnesium 25, and magnesium 26. So we got 3 different kind. Okay, so look it up, the percentage. What's the percentage? And then we calculate the average, which is the weight average. So take the fraction of isotope 1, mass of isotope 1, fraction of isotope 2, mass of isotope 2. A fraction means if something is like 10%, mean 10 over 100. 26.9% mean mean 26.9 over 100. That's what we call fractions. These are just make-up numbers, of course. Okay, and in the homework we do have a good example on that one, isotopic calculations. Okay, ions generated when atom donate or accept electron. Remember, one electron loss mean donations, plus one for each electron loss, negative for each electron gain. Okay, so if something has a plus one charge, that's mean one electron loss. The atomic number 55, that means 55p, okay? But it can't have 55, so it's 55, supposed to have 55 electron, but lost one, so it's 54 electron. So you think about it, 55p, that's 55 plus, 54e, that's 54 minus. Okay, and therefore it's a 1 plus charge overall. All right. Now, and then with that same idea, give a try on the rest of them. 54 electron, that's 54 minus, 53 plus, so it's going to be 1 minus, okay? And 55, if you look it up, it should be on the period table. You can look up the number 55. I believe it's cesium. Atomic number, okay, from the atomic number you can identify the number of protons, you can identify the elements, or the atomic number also identify the elements. Okay, and then so work on those and check with me in the class. Now 24 electron plus 3 charge, so 24 electron is 24 minus plus 3 charge, so it's got to have 27 positive, because 24 minus 27 positive, you get a net of plus 3, so that's mean 27p, and that's the atomic number. And then from there, look at the period table and you should be able to figure out the elements. Okay. All right. In the next video, we'll be talking about atomic weight, atomic mass, and then before we go into the naming stuff, fun stuff, definitely, how to name compounds. Okay. Atomic mass, atomic weight, they are all given on the period table. Actually, we can talk about this real quick. If you look it up, it's 22.99. You look up oxygen, it's about 16, and oxygen is 32.07. So all this you can pull out from the period table. AMU, that's the atomic mass. Okay, and be familiar with the period table, the metal on the left side, the non-metal on the right side, and stuff like that. Know the name, very important, because we're going to be using that to name compounds. Okay, I'll see you guys in the next video for naming compounds. A few different type of compound: ionic compound, covalent compound, acid, hydrate, so those are the compounds we're going to be naming. Okay, everyone. Thank you for watching, and see you guys soon.